Hello, my name is Javier Solis Salazar, and this is my experimental investigation project. My experiment relates with common curiosity about a certain question that says gravitational pulling force is equal for everything, and if the gravitational pulling force is equal for everything, then why objects inside Earth fall at different speed and reach like pendants at the end of pendants different depending on their weights. And this is a common question, and my experiment wants to explain why they fall differently. So the theory is related with the ideal free fall theory that says that in vacuum conditions, meaning where there's no air, there's no friction, objects will be purely pulled by gravitational force, so they will reach the end, or they will fall at the same time. But in Earth, on our planet, we don't have those conditions. So our hypothesis, or my hypothesis, is that in our planet, considering all its characteristics, objects with great masses will fall and displace faster than those with light ones. So my hypothesis will be experimented using the following things. I'm gonna select 6 different balls and I'm gonna let them go through a pendant. And in my experiment we can find many variables, but the important ones are the independent, which is the mass of the ball, the dependent, which is time, dependent to the mass of the ball, and control, which is the length of the pendant, and also the angle of inclination of the pendant. So the materials are 6 different balls, as I mentioned. The first one with 8 grams, 10 grams, 20, 26.6, 45, 155 grams, and a chronometer, a bascule to measure the weights of, the masses of the balls, and the pendant with the 25 degrees of inclination. Here you can see the prototype where I based my experiment, and then we're gonna take it to outdoors in order to make the experiment. So this is the application of the experiment, where we can see how balls are running through the pendant and finally reach the end of it. So at the time I let go the ball, I start my chronometer, and when they reach the end of the pendant, I stop the chronometer, and then I write down the values in a specific chart, which is the following: the mass and the time. So here we can see that the ball with 8 grams fall to 10.1 seconds. It lasted that time to reach the end of the pendant, but for the bigger one, it took only 5.93 seconds. So here we can say, or we can see, that our hypothesis is true. We can observe the graph, which is the behavior of the experiment with the corresponding uncertainties. And so after watching this, I conclude that the hypothesis was true. The heavier objects fall or displace faster than lighter ones. And ideal free fall theory is not applicable on this experiment or on Earth, because the conditions applicable for ideal free fall theory are not those conditions that Earth has, because Earth has air, has also friction and many other elements which cannot let ideal free fall theory be acceptable on Earth, or at least on this experiment. So this is the bibliography where I took the information about ideal free fall, and also about a research I did about the characteristics of the air in my city, like air density, air pressure, and so on. So thank you very much for watching this video, and I hope you understood the experiment.